Greetings, fellow nerds. In this video, we're going to grow tiny crystals of silver metal under the microscope. We're going to grow crystals by electrochemistry. The setup is actually fairly simple. I've taped down an aluminum wire cathode and a silver wire anode to this plastic tray. It's connected to these batteries through a 470 ohm resistor to limit the current. Now the electrolyte is a saturated solution of silver nitrate that I'm applying between the electrodes. I don't need very much since we're going to be doing this under the microscope. Now to slow down evaporation, I'm putting this glass slide over the drop. This has the advantage of making the surface shape flat and allowing us to easily focus under the microscope. Okay, let me take it to the microscope. The deposition occurs on the cathode or negative terminal, so that's where we'll focus our attention. I haven't connected the battery and resistor yet, so that gives me some time to do so. Now first we'll look at the highest magnification at the tip. Let me connect the power through the resistor, and look at that! Those are microscopic crystals of silver metal growing at the tip of the aluminum wire. I'm actually time-lapsing this as the growth is actually very slow and occurring over the course of 3 hours. As it progresses, you'll notice the crystals getting all deformed and no longer looking like perfect crystals. Two things are causing this. First, the crystals are hitting the glass cover. Second, growing crystals electrically is not an even process since the parts with the highest charge density grow fastest. Since charge density is not uniform for an irregularly shaped object, crystal deformation is really hard to avoid. Nonetheless, the time-lapse results are still spectacular. Let's try that again. This one I filmed over the course of 10 hours, and under time-lapse you'll see a lot of things happening around it as it grows. This is actually me fighting off various side effects like bubbles forming and the solution crusting over every hour, forcing me to keep removing and cleaning the slide. Every time I did so, I disturbed the crystal growth, and thus it became even more deformed. Nonetheless, we're still seeing actual pure silver metal electrically crystallizing out of solution. Not a salt or metal ion, actual raw metal. This is not something most of us will ever see in our lifetime. So what's happening is that at the anode, which is not on screen, the silver metal is dissolving and releasing silver ions into solution. At the cathode, the silver ions are electrodepositing onto the aluminum wire to form silver metal. It's a very simple reaction, but it's quite amazing when you have a microscope to see it. I'm using an aluminum metal wire as the cathode simply because I don't have another silver metal wire available. Here I tried again using a diluted silver nitrate solution. Since it's not saturated, it doesn't crust over as quickly or produce as many bubbles, letting me film longer without disturbing the growth. But as you can see, instead of hard crystal edges, the dilute silver nitrate grows a more feathery appearance of many smaller crystals. Kinda looks like I'm growing a silver tree, a microscopic one. Now so far I've been limiting the current with a resistor to get a slow and controlled growth. Now I'm going to apply the voltage directly to the electrodes. Ready? Go. That is not time-lapsed. That growth is actually happening in real time with a much higher current. The solution doesn't have time to diffuse in and form large crystals, so instead the crystals grow outward in branches composed of many smaller crystals. Okay, I've stopped the current. These branches are actually quite fragile and will easily fall apart. Now I'm putting the resistor in and going with the slow growth while time-lapsing the video. You can see the branches get thicker as now the solution has time to diffuse in and deposit the silver more evenly. But you'll notice the tips are growing faster than the stems. This is because the charge density is greater at the tips. Let's try that again. This time I'm going to use that large silver crystal hunk we grew slowly a few runs back. Let me prepare the slide and get everything into position. I'm also using a saturated silver nitrate solution for this particular run. I'm going to apply the current now. Whoa, that was different. Now look at that. We've got a few things happening here. Okay, I've turned off the current. Let's examine our handiwork. Look at that. Those branches are composed of different sized crystals, but mostly cleanly formed. Back here at the base, the original crystal hunk is now coated with a fine layer of small crystals, kind of like frosting. Looking around here, oh, look at that now. Looks like some kind of silver metal plant. I bet you some sci-fi filmmakers are getting ideas for an alien world from this. Anyway, I hope you like this simple experiment into the microscopic beauty of electrochemistry. Thank you very much for watching. Please subscribe, like, and comment.